In this video, I will be telling you all about rainbows and what they do. A rainbow is an arc-shaped spectrum of light which is created by refraction and reflection. Rainbows are caused when rays of light from the sun hit water droplets when reflect some of the light back towards an observer. The water droplets are usually raindrops, but could also be spray from a waterfall, a fountain, or even fog. To see a rainbow, you must have the sun shining behind you and the water droplets in front of you. Sunlight is made from a spectrum of different colours that look white when we see them all mixed together. Since light travels more slowly through water than air, the light is bent as it enters the raindrop and becomes refracted, splitting the light into the spectrum of colours. Some of the light is reflected off the internal surface at the back of the raindrop, which works like a mirror to reverse the order of the colours to provide the familiar sequence. The amount of rainbow arc that is visible depends on how high the sun is in the sky. When the sun is very high, you may see a rainbow that only just appears above the horizon. On the other hand, if you were lucky enough to see a rainbow from a plane or on top of a mountain, you might be able to see the whole circle. Part 2 is about a question that you might be wondering, what is a double rainbow? Now, they are formed when sunlight is reflected twice within a raindrop with the violet light that reaches the observer's eye coming from the higher raindrops and the red light from the lower raindrops. What is a double rainbow, you might ask? Well, a double rainbow is a wonderful sight where you get two spectacular natural displays for the price of one. Surprisingly, this phenomenon is actually relatively common, especially at times when the sun is low in the sky, such as in the early morning or late afternoon. The second rainbow is fainter and more pastel in tone than the primary rainbow because more light escapes from the two reflections compared to one. The secondary rainbow is also dispersed over a wider area of the sky. It is nearly twice as wide as the primary bow. A key feature of double rainbows is that the colour sequence in the second rainbow is reversed. The dark band between the two rainbows is known as Alexander's band, after Alexander of Arthrodisius, who first described it in 200 AD. The band forms because between the deviation angles of the primary and secondary rainbows, none of the sunlight is scattered by the raindrops towards the observer, given the band of dark sky. Now, how are they formed? Now, double rainbows are formed when sunlight is reflected twice within a raindrop within the violet light that reaches the observer's eye, coming from the higher raindrops and the red light coming from the lower ones. This means the sequence of colours is inverted compared to the primary rainbow, with the secondary bow appearing about 10 degrees of the primary bow. Part 3 is a question about. Now, this third question is about what it looks like. Now, this is quite rare. Have you seen an upside down rainbow before? Well, if you haven't, I'm going to tell you some history about it. Now, this is an arc called a circumzenithal arc. It happens as an optical effect which looks like an upside down rainbow. A circumzenithal arc, sometimes known as Bravais arc, is a type of halo. They are formed when sunlight refracts through horizontal ice crystals at such an angle that the light enters the crystal through its flat top face and exits through a side prism face, causing the distinctive upside down effect. They are commonly associated with the cirrus clouds, where ice crystals readily form. Circumzenithal arcs are actually quite common, and these type of clouds occur throughout the year. However, we only sometimes see them as they are usually obscured by clouds underneath. In order to be able to see a circumzenithal arc, a combination of atmospheric conditions must coincide. The height, depth, and position of the ice clouds must be right at the cloud needs to be at a specific angle convex to the sun. The position of the observer is also important since its visibility can vary greatly over short distances. Our fourth part is called a full circle rainbow. Now, to be able to see a full circle rainbow, you need to be able to see water droplets below your observable horizon. If you are standing on top of a tall building or looking out of an aircraft, then you may have water droplets in the sun. You might be thinking, what is a full circle rainbow? Now, the key factor that determines how much of a rainbow we see is our visual reference point. In most cases, we can only see less than half of a circle, the characteristic rainbow arc we are all familiar with. However, if you are lucky enough to be in the right position at the right time, you could see a full circle rainbow in all of its splendor. A rainbow center is directly opposite the position of the sun in the sky, so more of a rainbow can be seen as the sun approaches the horizon. Therefore, you will normally see the greatest percentage of a rainbow, 50%, at sunrise or sunset. Now, you might be thinking how they are formed. Now, to be able to see a full circle rainbow, you need to be able to see water droplets below your observable horizon. If you are on the ground, you are very unlikely to be in the optimum position to see the rest of the rainbow, except for full circle rainbows that appear in, for example, the mist given off by a garden hose or sprinkler. However, if you are standing on top of a tall building or looking out an aircraft, then you may have water droplets and sunlight below your observation point. That's all for rainbows today. Now it's time for some cloud learning.